Much like we did with logs, we're not going to go into the theory behind the derivatives of exponentials, but want to show you the two rules. If we are simply taking the derivative of e to the x, the derivative is in fact e to the x. And if we're taking the derivative of e to some function, we apply that chain rule and do e to that function times the derivative of the function. Applying those rules here, we get the derivative is going to be 3x squared plus the derivative of e to the x, which is simply e to the x. Here, we need to apply the product rule. So again, we take the first term times the derivative of the second, and the derivative of e to the x is indeed e to the x, plus that second term times the derivative of the first, which is 2x. Notice that leaves us with x squared e to the x plus 2x e to the x. And you can factor that if you wish, pull out an x, e to the x from both terms, leaving us with x plus 2. In this case, we are taking a derivative of e to a function. So we apply the chain rule. We still keep e to that same function, but then we're going to also take the derivative of that function, which is 2x plus 3. It's important that you leave that 2x plus 3 in parentheses to make sure you indicate that the entire thing is multiplied by e to that power. Lastly, here we're still going to apply that product rule, but then also the chain rule. So our first derivative is going to be the first term times the derivative of the second, and the derivative of e to the negative x is e to the negative x, but then we must also take the derivative of negative x, which is -1, plus the second term times the derivative of the first, and derivative of x, e to the x, I'm sorry, of x is 1. This leaves us with -x, e to the negative x, plus e to the negative x is our derivative.